Important questions in integral calculus. Question number 1. Integration log of log x plus 1 upon log x whole square dx. Here we integrate first term and second term will automatically get cancelled. So let's see how. So here we integrate it. So it becomes, we assume it as first function. So log of log x and 1 as second function. So integration of 1 dx minus d upon dx of log x into integration 1 dx whole dx plus integration dx upon log x whole square. This term is written separately. Now integration of 1 dx will give x. So x log of log x minus integration d upon dx of log x will give 1 upon log x times 1 upon x, and integration of 1 dx will give x whole dx plus integration dx upon log x whole square. It will become x log of log x. Here x will cancel out and we will have integration dx upon log x plus integration dx upon log x whole square. We further integrate it. We take 1 upon log x as first function and 1 as second function. So x log x minus 1 upon log x into integration of 1 dx minus d upon dx of 1 upon log x into integration 1 dx whole dx plus integration dx upon log x whole square. Now next step is it will become equal to x log of log x minus 1 upon log x times this, so it will become x upon log x because integration of 1 is x and it will remain intact minus, here if we differentiate it, so it will become log x power minus 1 and then d upon dx of log x power minus 1 will become minus 1 upon log x square times d upon dx of log x, that will be 1 upon x. So we will get this will become plus 1 upon, here there will be integration symbol and it will be 1 upon log x whole square into 1 upon x, and because of this minus sign has become plus into integration of 1 dx will give x then dx. So plus next term, so plus this integration dx divided by log x whole square. So it will become x log of log x minus x upon log x, and this x will cancel out and this minus sign will make this integration negative. So dx upon log x square plus this term integration dx upon log x square plus c. These two terms will cancel out and we will get answer as x log of log x minus x upon log x plus c. Now, question number 2. Question number 2 says integration root of tan x plus root of cot x dx. So this can be written as root of tan x plus root of cot x times root of tan x divided by root of tan x dx. Now we take root of tan x common, root of tan x, then root of cot x, and this root of tan x will become 1 upon root cot x, so that will become cot x. So 1 plus cot x dx. Here we put tan x equal to t square. Tan x equal to t square. We differentiate it. So this will become sec square x dx equal to 2t dt. And the sec square x is 1 plus tan square x. So 1 plus tan square x is t square. So 1 plus t power 4 times dx will become 2t dt, or dx becomes 2t dt divided by 1 plus t power 4. So we will get integration since root tan x equal to t, or tan x equal to t square. So from here we will get t, and this will become 1 plus 1 upon t square times this will become 2t dt divided by 1 plus t power 4. Now from here this will become 2t square. So 2 can be taken common, and then this will be t square. So t square times 1 plus 1 upon t square whole divided by 1 plus t power 4 d. If we take this t square inside, so we will get twice of t square plus 1 divided by 1 plus t power 4 dt. Now we divide each term by t square. So we will get twice of integration. When divided by t square, it will become 1. When this is divided by t square, it will become 1 upon t square. And in denominator, when this is divided by t square, so it will become 1 upon t square, and this will become t square and dt. Now we know that t minus 1 upon t whole square equal to t square plus 1 upon t square minus twice of t into 1 upon t, that will get 2. So here we have 1 upon t square plus t square. So we can find the value of t square plus 1 upon t square as t minus 1 upon t whole square, and this 2 is taken to LHS, so it will become plus 2. So we can write it twice of 1 plus 1 upon t square dt divided by t minus 1 upon t whole square plus 2. Now let t minus 1 upon t equal to u. So this will become 1 plus 1 upon t square dt will be d. So we will get twice of this du divided by u square plus 2. Now, if you remember, integration dx upon x square plus a square equal to 1 upon a tan inverse x upon a plus c. So here a will be root 2. So we can write it 2 upon root 2 tan inverse u upon root 2 plus c. We put the values. So this will become root 2 tan inverse, and u is t minus 1 upon t divided by root 2 plus c. But we have assumed tan x as t square. So if we take LCM here, so what do we get? It will become root 2 tan inverse. This will become t square minus 1 upon t root 2 plus c, which is further equal to twice of tan inverse. In place of t square, we can write tan x. So tan x minus 1 upon t equal to, from here, t will be root of tan x. And this 2 is also in root. So root of 2 tan x, we can write 2 tan x plus c. Let's go to next question. Here we expand sine x plus alpha by using formula sine a plus b equal to sine a cos b plus cos a sine b. So we will get integration dx upon root of sine cube x, and this will become sine x cos alpha plus cos x sine alpha. Now we can take out sine x from here. So it will become integration dx upon root of sine power 4x, and inside we will have cos alpha, and this will become cot x because sine x will divide this term and sine alpha. This can be written as sine square x by removing square root, and 1 upon sine square x will become cosec square x. So we write it cosec square x dx divided by root of cos alpha plus cot x sine alpha. Now we take this, like this term inside the square root as t. So let cos alpha plus cot x sine alpha equal to t minus cosec square x sine alpha dx equal to dt. We have cosec square x dx. It means cosec square x dx equal to minus dt upon sine alpha. So we will get minus 1 upon sine alpha integration dt upon root t, which is minus 1 upon sine alpha, and this will become t power minus half, and t power minus half when integrated, it will give t power plus half divided by half. So we can say t power half and times 2. So this will become minus 2 upon sine alpha times root t, and t is after we can write c. So here t equal to the whole term So root of cos alpha plus cot x into sine alpha and plus c. Now here, if we simplify this cot alpha further, so what do we get? Here we can simplify like we continue minus 2 upon sine alpha, and this thing can be written as cos alpha plus this is cos x upon sine x and times sine alpha plus c. If we take LCM, it will be minus 2 upon sine alpha and root of sine x cos alpha plus cos x sine alpha divided by sine x plus c. Further, we can apply the formula sine a plus b in numerator. So we get minus 2 upon sine alpha root of this will become sine x plus alpha divided by sine x plus c, which is our final answer. Now, we have integration dx upon cos x plus a cos x plus b. Now, we have to create the same thing in numerator in terms of sine. So, we multiply and divide by sine a minus b and sine a minus b times cos x plus a cos x plus b times dx. This we can take out. So 1 upon sine a minus b. And here we introduce x. So we write it sine x plus a minus, this is line bracket, x plus b dx. Net effect will be xx will cancel out and we will get a minus b, and that is why in denominator sine a minus b is there, and this is cos x plus a cos x plus b. Now we expand the numerator by using formula sine a minus b, sine of a minus b integration sine x plus a cos x plus b minus cos x plus a sine x plus b dx divided by cos x plus a cos x plus b. Here, if we divide separately, then from first term cos x plus b will get cancelled, and from second term cos x plus a will get cancelled. So what do we get? We will get sine a minus b integration. Here cos x plus b is cancelled, so sine x plus a divided by cos x plus a minus, here cos x plus a gets cancelled, and we will get sine x plus b divided by cos x plus b whole dx. Here, if we take this cos x plus a as t, we will get, suppose we write cos x plus a equal to t minus sine x plus a dx equal to dt. So this will become, so this will become 1 upon sine a minus b integration. This will give minus sine minus dt upon t, where cos x plus a is taken as t, and second term will become, this will become, suppose this is t1, so dt1 upon t1. Now we further simplify. So what do we get? 1 upon sine a minus b, and this will become minus log t plus log t1 plus c. Now we put the values of t and t1. So it will become 1 upon sine a minus b, and this is, we can write formula log m minus log m, which is log m upon n. So log t1 upon t. So t1 will be x plus b, and t will be x plus a. Here we can put modulus and plus c, which will be our answer. Now let's take next question. Sin x dx divided by sin x minus a. Let x minus a equal to t, then x equal to a plus t, and dx will be equal to dt. So we put sine in place of x, we write a plus t, and dt divided by sine t. We open the bracket by using formula sine a plus b. So integration sine a cos t plus cos a sine t dt, and we divide each term separately by sine t. So here sine t will cancel out, and here if we take sine t equal to u, we will get cos t dt equal to du. So let sine t equal to u, cos t dt equal to du. So this will become sine a integration du upon u plus second term cos a integration dt only, because cos a is constant. So we will get sine a times log u plus t times cos a plus c. Now here we have taken sine t equal to u, so this will become sine t, and then t equal to x minus a. So going back, so our integration will become sine a log of u. U means here sine t, so sine of x minus a plus t equal to again x minus a times cos a plus c. This is our answer. Now let's go to next question. Integration dx divided by x root of ax minus x square. So here we put x equal to a upon t, or dx will be minus a upon t square dt. So I equal to minus a upon t square dt. So minus a upon t square And in place of x, we are writing a upon t, and root of a into a upon t minus a square upon t square dt. So it will become integration minus a dt divided by 1t will get cancelled, and we will have t into a root of, if we take LCM, so it will become t square, root is extended to here, t square, then it will become a square t minus a square. So further, minus a integration dt divided by 1t we can take out from here. So this will become t upon t, and 1a also we can take out from within the square root. So it will become a square. Then inside the root, we will be left with t minus 1. So 1a is cancelled and t is completely cancelled. So we are left with minus 1 upon a integration 1 upon root of t minus 1, or we can write it t minus 1 whole power minus half. So we can integrate it. So if we take t minus 1 equal to u, dt equal to du, so we can directly do it. So minus 1 upon a, t minus 1, and power will increase by 1, that is 1 by 2 divided by 1 by 2. So that will become minus 2 upon a, and this will become root of t minus 1 plus c. So we put the value of t, and t equal to a upon x. So this will become minus 2 upon a, root of a upon x minus 1 plus c, or we simplify minus 2 upon a, root of a minus x upon x plus c, which is our final answer. Thank you for watching.